So today I'm going to be talking about differential statistics, t-test, ANOVA, and chi-square. So first, I want you to understand what differential statistics are. And these are tools that help us to identify whether we can observe a pattern in a smaller data set when compared to a broader data set. What do I mean by this? Let's say you walk into a college full of students, and you enter a particular class, and you want to measure the glucose level in that class. When you measure the glucose level and you get the mean of the glucose level, you may want to compare it to the rest of the students in the college. So these are tools, they are tools that we use to compare these things, and those tools are the t-test, ANOVA, and the chi-square. So these are called differential statistics. You want to compare these things to know if there's actually a difference or if there's no difference. You want to know if those students you measured, if their glucose levels are going to be quite similar to the glucose levels across the whole school, or if there'll be difference. So these are just tools that we use to measure these things. So before I go on into t-square, ANOVA, and chi-square, I want to quickly touch on numerical and categorical variables because you need this to understand those. So numerical variables are measurable quantities. These are hard numbers such as blood pressure. You can measure blood pressure and count them. You also have the respiratory rate, the pulse rate, the glucose levels. These are numbers you can actually measure and count. However, the categorical variables, these just represent types and groups, such as gender. Although there are a lot of genders now, but genders are not something we measure. Genders are not something we count. And we also have the eye colors. There are different eye colors, but these are not numerical variables that we can measure. And also diseases like lung disease, diabetes, hypertension, these are not variables that are numbers that we can measure. So I will need you to understand this too, because they'll be important in understanding the different differential statistics. So I'm going to begin with the t-test. So the t-test compares two numerical variables. You know, I just talked about these variables. So numerical variables are variables that are numbers. So the t-test compares two numerical variables between two groups. What do you want to see? You want to know if there is a statistical difference between these two groups. Usually when comparing two groups, there you always surely find a difference, whether the difference is 10, 1, 0.1, 0.001. However, in statistics, there's something we call statistical significance, statistical differences. So essentially, you're comparing these two groups to know if these groups are really different or if they are the same. You want to know if they are statistically different. So there are various types of t-tests, but I'm going to focus on the two types that you will need. The first is the independent t-test. So this independent t-test compares two different groups. For example, you want to measure the blood pressure. First of all, blood pressure is a numerical variable, so it fits you using a t-test. You want to measure the blood pressure in a set of patients using two different medications. So now there are two sets of patients, which is two groups, and this is the blood pressure you're measuring, which is a numerical variable. So you can use the t-test to know if there's going to be any statistical difference in the blood pressure between these two groups. And then the second type of t-test is the paired t-test. So this t-test uses one group. It uses the same group. However, it measures the difference between this group at different times. I'm going to give you an example. For example, you have a group of 10 patients, but you want to measure their glucose level in the morning and in the evening. Or you want to measure their cortisol level in the morning and in the evening. This is the same group, but these are at different times. So using the paired t-test can help you measure these groups effectively well and help you know if there is a statistical difference in the mean of the glucose or the cortisol levels you get. I mean, that is one of the ways we found out that cortisols are higher in the morning and less in the night. And moving on to ANOVA. I see ANOVA as an extended t-test. T-test measures two groups. ANOVA measures two or more groups. However, you should know that ANOVA is still measuring numerical variables. They are trying to compare their means and know if there's a statistical difference between these variables. It's just the only difference between ANOVA and t-test is that t-test measures just two, ANOVA measures more than two. For example, you want to measure the cholesterol levels across 3 diets. So cholesterol level here, measuring across 3 diets. Cholesterol level is the dependent variable because it changes based on the diet. The diet is the independent variable. So these are 3 groups, 3 different diets. So you cannot use the t-test for this. You have to use the ANOVA because there are 3 different groups here. The same thing with measuring the mean height of women in clinics A, B, and C. You can see that clinics A, B, and C are 3 different groups. You want to know if the height of women vary across these 3 different groups. So you have to use an ANOVA because the height of women is something that we can measure. It's a numerical variable. And then there are 3 different groups. So an ANOVA fits the bill in this case. And then lastly, I'm going to talk about the chi-square. The chi-square measures categorical variables. This is the difference now. The chi-square does not measure numerical variables. The chi-square measures categorical variables between 2 or more groups. You want to know if there's a statistical difference between these variables. And I want you to understand that categorical variables do not have a mean. You can get a mean for pulse rates. 10 people, you can measure the pulse rate of 10 people and get a mean, but you cannot get a mean of gender. You cannot get a mean of eye color. So categorical variables do not have a mean. So you need the chi-square to see if there's a difference in these groups. For example, you want to measure the proportion of individuals with diabetes across 4 ethnic groups. Diabetes is a categorical variable. The ethnic groups are also categorical variables. And so you have to use the chi-square to measure this. So in summary, the t-test measures 2 groups, numerical variables between 2 groups. The ANOVA measures 3 groups, numerical variables between 3 groups, while the chi-square measures 2 or more groups, and these are categorical variables. Thank you.